All right, tonight's homework is a little bit more complicated than the previous night's homework. The good news is that you will always be finding Q. The bad news is that you're going to be having to deal with both phase changes and temperature changes. The key ones that you need to remember are 0 degrees Celsius and 100 degrees Celsius, especially when it comes to water. So when you read this question, okay, I see that I have an initial temperature or initial mass, okay, of 450 grams, and then I start at an initial temperature of 20, and then I keep heating up until it's all boiled away. And then they ask me, hey, what's the total energy in this whole scenario in kilojoules? Okay, so what I would need to do first is it's very, very, very important for you to draw these graphs, okay, the heating and cooling curve graphs. And I know I'm starting at 20. You always want to think, are you going past 0 or 100 at any of these times? And at 20, I've already passed 0, but I'm going up until it's boiling. So I'm going to go up to about 100, not about, it will be exactly 100. And then what happens is I undergo my phase change of boiling, so it levels off. Now if I look at this, I am going to have both a Q equals HM, and I am going to have a Q equals MC delta T. Right? And for these, you're going to need to do both scenarios, okay? So I'm first going to deal with, but you deal with them at separate times, okay? So what you're going to need to do first, I'm going to deal with the heating up of this substance. So I'm going to write, hey, this is when I'm heating up. Heating up, and I'm going to say it's from 20 degrees all the way up to 100 degrees. And I do like to label them because they will get even more and more confusing. Okay, so during this time, I am using my Q equals MC delta T. And I look at my formula, and I know Q is what I'm solving for. My mass, I'm going to look in the equation, and I know that it's 450. It will be 450 for this entire problem. I'm going to look at my C values. The thing with the C values is we will be dealing with all of the specific heats of water. At 20 degrees, I need to know that it's going to be a liquid, so I'm going to use the 4.18 value. And then my delta T, well, I'm going to look at it. I know I need to start leveling off at 100. So I'm going to take my final minus my initial. So it's going to be 100 minus 20. Right? Now I'm going to simplify a little bit. So I'm going to do 450 times 4.18 once again, which is my C value for liquid water, times my 100 minus 20, which is 80. I'm going to plug this into my calculator, and I'm going to have 150,480. My unit is joules. Do not round for sig figs until your very, 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 very final answer. All right, so this is the heating part, so that would be representing here. Now I need to deal with, I've already dealt with this part, now I need to deal with the leveling off part, or the phase change where it's boiling away. So I'm going to need to use the HM formula, so Q equals HM. So in this case, Q equals, my H value for boiling is when it is the same value as heat of vaporization, okay? Because vaporizing is going from a liquid to a gas, boiling is going from a liquid to a gas. So I'm going to be using that value. And I look on my front of my sheet, or at the top of my sheet, and I notice that that value is 2,260. I'm going to multiply by, once again, the mass that was found in the original problem, and that would be 450 grams. So when we multiply that out, it is going to be 1,017,000 joules. Okay. Now the total energy that was utilized is both the heating up and the boiling away. So what you're going to need to do is add both of these numbers together. So I'm going to add the 150,480 to the 1,017,000 to get my final answer of 1,200,000. Okay, Actually, what you would get is 1,167,480, but rounded to your 2 sig figs, because 450 has 2 sig figs and that 20 degrees Celsius has 2 sig figs, you would end up with 1.2 million joules. Now, all I expect my kids to do is move over the decimal to get to kilojoules. You can either do that or set up a proportion, but you're going to move it over 1, 2, 3, because there's 1,000 joules in 1 kilojoule. So your final answer will be 1,200 kilojoules. Okay. Hopefully you kind of understand that, and there will be more problems like this to come.